Okay, so welcome to Science Fun Day at the Observatory. My name is Sharon Morsink. I'm a professor here in the Department of Physics at the University of Alberta, and I'm in our observatory right now. And I'm going to be showing you around our telescopes, and maybe you'll even get a little right now we're in the indoor classroom area, and so if you ever visit here with your class, kids will sit in these chairs over here. Astronomer gets a presentation with a model of the James Webb Space Telescope up here. It was recently launched on Christmas Day. We've got a really good evening with this telescope. Very nice Thomsonian telescope to look at the moon and the planets and stars and our model of the gravity belt. We can take a look at this later on after. And we have Katie. So what we're going to do is we're going to step outside. Now, you want to first just take a look and see what it looks like out here. We have patio area. And you can see 3 domes. 1, 2, and 3 domes. So we'll look at all of these domes. This telescope, this dome has our biggest telescope, 20 in diameter telescope. The middle dome has an 11-inch telescope, and the far dome has a 14-inch telescope. And you'll see what I mean by that. If you want to just take a quick look around, so campus, that area with the snow is called quad. The world of science, which is the black circle cut on an angle. So, if you ever visited Tell's World of Science, there. We start off by going into the middle dome and get the telescope set up. And if you have questions, you can just raise your hand and ask questions, and I'll be happy to answer questions as we go. So the first thing we're going to do is we're going to go with the dome. The reason why we keep telescopes in these domes is that a lot of these telescopes are really heavy, and so it'd be really difficult to take them out from the closet and have them up on here every day or night. And so we like to keep them set up, but if it rains, you destroy the telescope. So we have to protect the telescope. So what we're going to do is I'll first turn on the lights. Let's open it up. We won't need it. Now I'm going to open the dome, and you'll see this tall lid to open up. You want to look at the sun, which means to get the sun. We look at the sun. One of I'm going to do is I just want to rotate the dome a little bit, make sure we don't have any light falling on the telescope. We're actually pretty good, but I'm just going to show you the rotation. Give you now I'm going to take off the depth cover. And then I'm going to get the solar filter. And so it's dangerous to look at the sun through a telescope. The telescope concentrates the light and put a dangerous amount of light into the eyes. And you can't even use sunglasses to look at the sun. That would be dangerous as well. So instead you have a special solar filter. And basically, it seems like almost no light comes in. It's reflecting, but it actually allows a tiny bit of light to get through. And that'll be a safe amount coming from the sun. So I'm just checking it to make sure. Yeah, pretty good. Now I'm going to put it on the telescope. And so I just put, this is where all the light goes in. If we were looking at stars, we wouldn't use that. We'd be getting all the light from the stars. Nice and sweet. Okay, now I'm going to rotate the dome so that the light from the sun is going to fall on the telescope. Now the sky is not perfectly clear. You probably can't see it properly from here, but you can see that there's sort of a light cloud in front of the sun. But we can still see light from the sun. And if you put your hand in front of the sun right now, you'll see that there's an ice halo around the sun right now. I don't know, you probably can't do that. Okay, so we now have the sun on here. I now have to do some fine tuning to get the. What I want to do is I want to get the sun in here, and we're going to go. So I'm going to get the sun lined up properly. I'm going to put an eyepiece in. And you might have to close the door so that we don't get that beeping happen. Yeah. Right now, this is where I stood my cat and let it go look at it. Okay. Okay, done. Find that. Else that I do is I'm just lining up. I don't know if you can see my hand, but I'm lining up the image of the sun so that it appears in the middle of the circle. Oops. Okay, that's better. Now I want to make sure no one accidentally. Now, there's a little bit of cloud in the way, so it's not a great view of the sun. But I can see the sun as part of a white circle in here. Because of the cloud, I can't see any of the sunspot. You might want to... This view is not fantastic, but you can try to see it. See anything. Anyways, there's a bit of white light here, and if you were to look through there, you'd be able to see the sun. I don't know if there's any questions. All right. What type of thing can you see? Oh, okay. So with this telescope, we can see sunspots. Sunspots are places with stronger magnetic fields, and we have magnetic field lines, which are lines that are like spaghetti coming into the sun. And where the magnetic field hits the sun, it tends to be a little bigger. You see that as black spots on the surface. Through the next telescope that we're going to look at, we can also see things called prominences, which are arches of gas that go over the surface. And I was able to see some just a little bit earlier, so I think we're going to move over to that.
And what's the sun filter?
Oh, I'm not sure exactly what this one is made out of. It's a mylar type material and reflecting. I don't know what else. Now, this filter is something called a white light filter, and so it gives us the natural color of the sun, which is white. The next telescope has a different filter that is going to make the sun look red. Okay, so this is a similar telescope. In this case, we're not looking through the main telescope. We would just use this telescope at nighttime to look at stars and faint galaxies and nebula. Instead, we're going to be looking through this smaller white telescope, which is only used for solar observing. It has a special filter in it, which only allows the red light to get through. And if there's any questions, I'm happy to answer that. The sun, of course, emits all colors of the rainbow. And when you bring the light from the sun all together and look at it, it basically looks like white light. And that's what we could see in the other telescope. In this telescope, it filters out all colors except for red. It only allows the red light to get through. Now, the red light is emitted by an atom called hydrogen. And when it's in an excited state, it gives off this red color. And that's what we're going to be seeing here. So let's take a look and see. So in this view, we have the sun looks like a red ball. Why don't you see if you can manage to take a look there. If the clouds clear up at all, we should be able to see some prominences, which are the bits of gas sticking out from the surface. With the cloud, it tends to clear up the view and you can't see. I'm not sure if you can see it as a bit. Yeah, anyways, it looks better when you look at it yourself. Now, what we could do is we could go take a look at the bigger telescope. And if you'd like to take another look at Patio and see what we have here, you can see little cloudy, but still left. So these two telescopes we have set up so that we can look at the sun in the daytime. This telescope here is only used at nighttime because it's a really big telescope, and you don't need a big telescope to look at the sun. And so this is, as you can see, a lot larger than the other. We measure telescopes by the diameter of the mirror. And so the diameter of this mirror, we were to take the dust cover off, you would see that it's 20 inches across. Would you be interested in seeing what the inside of the telescope is like? Probably. Yeah, let's take a look. So I'm going to pull this down. I'm going to take off the dust cover. Yeah. Pull this down. Okay, can you see inside? So down at the far end, we have the main mirror. That's called the primary mirror. And that's where light from stars comes in. And the light from the stars will bounce against that mirror. And then right over here, we have a smaller mirror called the secondary mirror. And so light goes in, bounces against the big one, bounces off this smaller secondary mirror, and then goes through the hole in the center, and then goes through the eyepiece. And so this mirror is curved, which then helps us get magnification as well as reflecting the light. We have a question.
Why do you look at stars?
Why do I look at stars? Partially just for the wonder of being able to see things that are so far away from us, but also to help us understand a little bit more about our own solar system. This is one of the ways is that we can learn more about our sun, is by learning a little bit more about other stars, because our sun is another star, basically. But I just find stars fascinating. I like to know a little bit more about how they shine, and, how they make their energy. I think those are fascinating.
And when were telescopes?
That was in the 1700s. I can't remember the exact. we could figure that out. It's a bit murky about exactly who invented it. Van Lippershey was a Dutch astronomer and lens maker who sometimes credited. The first person to seriously spend a lot of time using a telescope to look at the stars, the moon, the sun, was Galileo. And so he really did the first serious work. He was able to see the moons of Jupiter, for instance, through the telescope. He could see the phases that the crescent and gibbous Venus went through. And so he made a lot of important contributions to astronomy, basically because he was the first to take a look at the stars through the telescope.
And do we know why stars are different colors?
Yes, it has to do with the temperatures. So different stars have different temperatures, and it turns out that when you have a hot gas, it glows a very particular color depending on its temperature. Now, you might think this sounds a little bit weird, but what we call low temperature corresponds to maybe about 4,000 Kelvin, and those are things that glow red. And then if something is really hot, like say 10,000 Kelvin, will be more of a bluish color, a very, very faint color. Do you have a telescope you would like to go back to, or would you like to look inside? Let's go inside. Follow me in here. Let's go back inside. We could go to the exhibits over there. common that we have a couple very old telescopes that were used by surveyors in the quite a long time ago in the 1800s. Like, so these are real antiques. We don't know the whole history, but we think that these telescopes were used when they were surveying the 49th parallel border between Canada and the United States. So that's quite and this is some crazy electronic equipment that was used back in the 1980s. Before they had digital cameras, they had to use a quantity like this to measure the light from stars. And then this thing over here holds the first digital camera that we had, which was in the 1990s. And so this big thing is just like a big holding device to keep the camera steady. And then the digital camera is just a little chip that's held in there. And this is like in the 1990s, this was like a state-of-the-art thing, and it was something like 256 kilobytes. Ridiculously bad. And here's our collection here. Do you like to see some space rock? Okay, let's take a look. So, what we got? So, this is an example of a stony meteorite. I'll just hold it in one place and you can move it so that it focuses properly. And so, this is the outer part of the rock that got kind of burnt up as it came through the Earth's atmosphere. You can see it's kind of black and kind of smoothed out a little bit. And then it broke up into tiny little pieces. And so this is what the inside looked like after it broke up. And you can see it's got little shiny bits, so little bits of iron. And some of them have really rusted a lot. This fell on November 20th, 2008, over Edmonton in the evening. And so a lot of people in Edmonton actually saw this come down. And there were a lot of video cameras that caught this. And so because they had enough information about the trajectory of the meteorite as it fell from the sky, they were able to figure out where it landed. And so people did the calculation, found out that it landed in Saskatchewan. And lots of people went on expeditions to Saskatchewan, and they found these little pieces close to a place called Lone Rock, Saskatchewan. And so this is one little piece of it. So this is a really important type of meteorite in that people saw it fall, and we have a lot of information about it. We can see it. And so this is one of many hundreds of pieces. Do you have a question?
Yeah, we just have a quick question. So one of our attendees asked, how hot is the star?
Oh, how hot is the star? So our sun, the surface of the sun is 6,000 Kelvin, which sounds hot, but it's actually a lot hotter inside. The very center of the sun is 10 million Kelvin. So it's hottest in the center and gets cooler as you go outwards.
Okay. And where can you buy a telescope?
Actually, I don't normally do commercials for telescope stars, but Alberta has one particularly good telescope star called All-Star Telescope. And they used to be located in Didsbury, Alberta, but they recently moved to Edmonton. I don't know their current location, but if you just look up All-Star Telescope, you'll find them on the internet. That's a place. You can also buy telescopes at Telescope Science, but I think they don't have quite as much selection as what they have at All-Star. So that's what I was.
Okay, and just one last question. How far can you see into space?
It depends a little bit on where you are, of course. In the city here, because we have a lot of light pollution, we need a big telescope. Generally, the part of this thing that we can typically see is called the Andromeda Galaxy, which is about 1 million light years away from us, which is reasonably far, but there are things way farther. There are things that are 10 billion light years away from us. So that's relatively. This over here, this meteorite that fell over Edmonton in 2008 is an example of a stony meteorite. But there are also iron meteorites. And so this one over here, if you were to touch it, you can see that it's kind of sharp, and it kind of exploded when it fell in. And so it's almost pure iron. It's gotten kind of rusty, but you can see a bit of the shiny edges over here where people handled it a lot. This thing fell approximately 1,000 years ago and fell just outside of the town of Whiteport. That's about 100 kilometers west of Edmonton. We don't know of any stories of this thing falling. Presumably the indigenous peoples living in the area would have known about this because it probably would have made a loud sonic boom, but I don't know of anyone who's discussed this about any legends. So we can just only estimate approximately how old this is based on the crater that was left. Let me show you my very favorite. Let's see if I. So I like those two because they're local meteorites. They fell in Saskatchewan or Alberta. Actually, before I do that, I'll just show you. Here's an example of one. Can you pull this up to the light and see the little shiny bits in there? That's typical of a lot of stony meteorites, is that when you cut them open, you can see that they're stone, but they have little metal flecks in them. And that has to do with the composition of the molten material in the early days of the solar system. And so these first solidified as rocks around the same time that the sun was born. It was about 5 billion years ago. It's 4.56 billion years ago, to be a bit more precise. Now, meteorites are rocks that are left over when bits of asteroids fall through the Earth's atmosphere and land on the ground. Sometimes they burn up and they're too tiny and they just burn up and we don't actually see anything, they don't actually make it to the ground. And we just see them as a streak of light. If we just see a streak of light, then it's called a meteor. And that's sometimes dust left behind by comets. And then larger rocks will leave little debris behind. But rocks also hit the moon. And when rocks hit the moon, they smash into the moon and material gets slammed upwards, kind of like this big splash. And because the moon doesn't have a very strong gravitational field, sometimes the splash up, the little bits of the moon's crust will escape the moon and fall into the Earth. And when little bits of the moon's crust fall on the Earth, we call it a lunar meteorite. And so this is an example of a lunar meteorite. And so this is a piece of the moon's surface which fell to the Earth. This is pretty cool.
I just have a question from one of our attendees. How cold is it?
Cold. I don't know the specific temperature, but it's probably on the order of like 30, maybe 30 to 100 Celsius. Many, a couple hundred degrees below 0 Celsius.
And you mentioned stony as well as the iron meteorite. What is the difference?
Oh, okay. Well, so first of all, the type of composition, but what has to do is where they came from. And when you have a large asteroid, what ends up happening is the heaviest elements sink to the core, and it kind of, same way that the Earth also has an iron core, and then the outer parts of the asteroid are more rocky because they're lighter material. That's similar to what we see with. So what happens is you have these iron cores, which are more or less iron, nickel, just really, really heavy elements, and then a crust, which is lighter. And then when one of these asteroids breaks up into smaller pieces through collision, what will happen is some of the pieces could be coming from the core, and some pieces will be coming from the crust of the asteroid. And so this iron meteorite over here is probably part of the core of a larger asteroid, while the rocky ones would be more likely to be coming from the surface layers of a larger asteroid, or it could have been coming from a smaller asteroid that just wasn't chemically differentiated.
And can we predict when meteors are going to hit Earth?
Okay, so generally not very well, actually. People can track larger asteroids, and so people are always worried about big things hitting the Earth. And so we have telescopes to monitor for big things that can actually be a real problem for us. But the types of meteoroids that created these things over here were fairly small, just objects that are maybe and those are ones that typically we can't predict, and they're not dangerous, except that, you know, if you happen to be at the wrong spot on the Earth, you could be in trouble. There's an example of someone in a car, they thought meteorite smashed their hole. But generally, you know, that isn't perfect.
And do you look at planets as well as stars?
Oh yes, yeah, we definitely look at planets as well. Right now, the most of the planets that you can possibly see are in the morning part of the sky. But when we get into the fall, we'll be able to see Saturn and Jupiter quite close to our.
Will humans be able to live in space in the future?
Well, that's a bit more of a biology and engineering problem. You have to, you know, living, say, on a different planet has a real issue because you need to have a dense enough atmosphere, plus you need to have the right chemical elements in it for us to be able to breathe it. So that makes it very difficult. And the temperature could be quite wrong. So it's quite difficult to actually live a long time on another planet. So far, the only thing that we've done is people have traveled to the moon, you know, short enough. I think that if we really wanted to have a longer stay on, say, Mars, it could be possible, but there's a lot of work.
And just one final question, what's your favorite planet?
I love them all, but you know, Saturn with its rings, it's got a certain beauty to it. I think that that's really marvelous. But so that's kind of my favorite. I really like Jupiter though, because all the little swirly hurricanes that it has. I think that's really cool. And then Mars is really cool too because it's got the ice caps and so many interesting geological features, like the solar system's largest volcano. So, I mean, that's hard to do. Of course, Earth is nice too.
So it looks like there is no more questions. Do you have any further questions that you want to?
Oh, I guess I'll say that all goes well. We'll be open for the public to visit us in September. We may have some possibilities in the summertime, but definitely in September.
Well, we'd like to thank you as well as the attendees for coming to this work. If that's all the questions. There's one more question, if you don't mind asking. Okay. How do you know when it's a meteorite?
So if you find a rock on the ground, you could just think that it's just a regular old rock, but I've got examples of things that are not meteorites. Sometimes we call them meteor rocks. Since no one minds being here for a couple more minutes, let me just show you. And so there's the difference. How do you tell the difference between, say, this and this. And so, first of all, a regular Earth rock, sometimes you'll be able to see that has layers, and you can't form layers in space. You don't have enough gravity. The other thing is that although these are both reddish color, this red, maybe this is an Earth rock over here, and it might have a tiny bit of iron in it. But it's not very much, and it's not magnetic. And so one of the things you do is you pull up a magnet, and you'll do this. Oh, actually, let me see if I can find any of the good magnets. So this thing over here is a really strong magnet, and nothing much happens here. But with most meteorites are very magnetic. They have large amounts of iron in them, and so that's usually your first step. So what you do is you find a strange rock and you say, "Oh, is it magnetic?" That doesn't prove that it's a meteorite, but it's like the first good step. The other thing too is that an iron meteorite has really sharp edges because they tend to explode. A rocky meteorite, as well as the iron meteorite, can have this kind of finish that looks almost like an eggshell, except that it's black instead of white. And that's kind of what it looks like when it gets burnt up. And so you can see that there's kind of this transition between where it got burnt up outside, and then here's the interior, what it looks like there. You'll often see metal flecks, although this one's been carefully cut open so that you can see it. If you've been handling it, it's hard to see the metal flecks because it gets dirty. And so those are the first couple things that you would do. The other thing is just that the density is quite different. And so you feel how heavy these two are. And I can feel that this one over here, which is the meteorite, feels much more heavy than this one, which is about the same size. And that's got to do with the composition being very different. Iron is a much heavier element than the silicate, which is rock.
Everyone, that's all the questions we have today. Thank you for the store, and thanks for all our attendees as well. You have a bit for here today.
Thanks so much for joining me here, and thanks for inviting me to give this tour.